All right, so continuing on, some more vocabulary related to arcs. We're going to talk about how to measure an arc. To measure a minor arc or a semicircle, so I'm just going to add that in there. So a minor arc or a semicircle, the measure is going to be the same as the measure of the central angle that it is between. So if you look at my diagram here, let's just say we have central angle ABC, and we know that central angle is equal to 60 degrees. Then the measure of the minor arc AC is also going to be equal to 60 degrees. So the measure of arc AC would also be equal to 60 degrees, same as the measure of angle, central angle, ABC. So they're always going to be the same. We know a semicircle is always going to be 180 since an entire circle is 360 and the semicircle is half of that. To find the measure of a major arc, that's always going to be 360 minus the measure of the central angle. So if I wanted to find the measure of the major arc that I'm going to highlight here in green, if I want to find the measure of this arc, I would just take 360 and subtract the measure of the central angle, which is 60 degrees. So the measure of the major arc would be 300 degrees. So that's what you need to remember about finding the measure of a minor arc versus a major arc. The next thing we're going to talk about are congruent arcs. So two arcs are congruent if they have the same measure. Now, something I want you to keep in mind is that arc measure is different than arc length. And we're going to talk about arc length later in the chapter, but I just want you to kind of be familiar with this idea and keep this in mind. We have a measure of an arc and we have the length of an arc. The measure of the arc is always measured in degrees. So how many degrees? The length of an arc is usually measured in terms of a fraction of the circumference. So for example, if you look at the concentric circle diagram I have over here to the right, if I draw a central angle, notice that this central angle, so I'm going to call this A, B, C, and then I'm going to call these points D and E. And let's just say that the central angle measured 40 degrees. Notice that that central angle is a central angle of the small circle and of the larger circle. So therefore, the measure of both minor arcs, so the measure of minor arc AB would be equal to 40 degrees. And the measure of arc DE would also have to be 40 degrees. So I'm going to highlight that one in red. Both of those arcs have the same measure, but obviously looking at them, they are not the same length. So that's what I want you to keep in mind. Arc measure is completely different than arc length. Okay, arc measure is how many degrees it is. Arc length is what fractional part is that arc of the entire circumference. Okay, so we're just going to be focusing on arc measures, so the number of degrees. So even if two arcs are not the same length, they can have the same measure. So just kind of keep that in mind when you're working through that. Okay, moving on. The last part of this section talks about 6 theorems relating congruent chords, arcs, and central angles. So rather than having you write out these 6 separate theorems, I'm going to combine all 6 of them into one. And then we're going to talk about what it means. So these 6 theorems combined basically say that in a circle, congruent chords mean congruent arcs, which also means congruent central angles. And vice versa. The reverse is also true, so I'm going to double side the arrows. So basically all you need to have is one of those 3 things, and then you are allowed to assume that the other 2 are going to be true. So I'm going to label this diagram with some letters here. And let's say that we were given that angle ACB is congruent to angle XCY. So we're given that we have two congruent central angles. Now the conclusion that we can make, there are 2 conclusions that we can make. So I said if you have congruent central angles, then you would also have congruent arcs. So we can conclude that the measure of arc AB is congruent to the measure of arc XY. So I could assume that these arcs are going to be congruent. And I can also assume that the chords are going to be congruent. So chord AB is congruent to chord XY. So that's what this theorem is saying. I have congruent central angles, so then I can conclude that I have congruent chords and congruent arcs. Let's say we had something different, so I'm going to erase what we have here. Let's say that we were given that the measure of arc AB is equal to the measure of arc XY. So we're given now the arcs are congruent. So what conclusion can we make? We can conclude that the central angles are congruent. So angle ACB is congruent to angle XCY. And we can conclude that the chords are congruent. So AB is congruent to XY. So that's kind of what this theorem is saying. All you need is one of those 3 things, and then you can conclude that the other 2 are also going to be true. So keep that in mind as you're working through examples. These 6 theorems are going to come in handy. Just remember what I have written up here.